Hello everyone, welcome back to Clear Creek Solutions hydrology education videos. Today we're covering measurement of stream flow and stage in rivers, so this is going to be a really good informative video. First, you can download the hydrology terms guide. It includes a really good key outline of 10, 20, 30 hydrology terms that are really useful in the industry, hydrology and hydraulics. Really help you understand some of the concepts that we were talking about here. Go to the link in the description. You can download that guide for 100% free. Before we get started, this is lesson 11. We're going to be going over stream gauge readings here. So let's talk about the measurement of stage. This is the most rudimentary device to measure river stage is a staff gauge. These staff gauges are usually read by an observer up to 2 times a day, so they can be read quite often, and they're stuck in they're just sort of placed in the river to measure that river stage. And if you don't know what stage just means the river height, or how much water in terms of height is accumulating. And streams that are subject to rapid changes are difficult to measure, and additionally some more equipment must be used. So the streams that are constantly changing, going up and down, maybe they have a dry and then a wet event, and the level is constantly changing these streams, the staff gauges are not that useful because you don't know which data point you are measuring. You could be coming in at a low point and then coming in at a high point, but for most of the day or for most of the time, the river was actually somewhere in between. You're not going to really get an accurate picture of what's going on in terms of the stage in the stream, so we need some more equipment to be able to measure it properly. The most common type of recording gauge uses a float connected to the recording mechanism in such a way that motion of the float is recorded on a chart, and so the motion of this float is then recorded so we can get more comprehensive measurement of the stage of this stream. And then a gauge house made of concrete, steel, or timber is used to protect that recording equipment and the float so it's not damaged during any sort of storm event or interrupted by the natural environment. The stage recording equipment must be upstream from the control, and then the current meter measurements may be made at any convenient section along the stream. So it's good to have the more data and the more sections that we're able to put these devices, the more accurate measurement obviously you're going to get of the stage measurement. It can be difficult sometimes to get accurate stage measurement, but it's very useful when it comes to hydrologic modeling and modeling that hydrologic cycle. Crest stage gauges have also been designed to provide a record of the highest stage observed at a station, so we can get sort of what that peak stage might be in the stream. Now let's talk about Streamflow units. In the US, flow is often expressed in cubic feet per second, and that is abbreviated as CFS. And you're going to see this value a lot, especially when it comes to flow. CFS is very critical. Meters cubed per second is also used when you're not using the US units, but for US and the study of hydraulics and hydrology, CFS is used quite often. You've probably stumbled across it quite a bit at this point. Volume of flow is often expressed in acre feet. An acre foot is the quantity required to cover an acre to a depth of 1 foot, or 43,560 cubic feet. So let me just explain this real quick here. So an acre foot, essentially, if you had an acre of flat ground, and then you had a 1 foot deep of water on that acre, that is an acre foot of volume. And this is a very common expression to be used when it comes to hydraulic analysis. And so that also does equal 43,560 feet cubed, but acre feet is a really quick measurement that off the top of people's heads they understand and they know what they're looking at. And then when discussing municipal water supply, volumes are expressed in CFS or sometimes more commonly millions of gallons per day. And there's actually a pretty quick conversion you can do there. If you take your millions of gallons per day, you divide it by 0.646, you can then get CFS and go back and forth with the conversion. But millions of gallons per day, because we're dealing with such large quantities, it's like 30 million CFS or 40 million CFS. It's not really a value we can wrap, or 2,000 CFS. It's not really a value we can wrap our head around that well. But millions of gallons per day, it's actually sort of easier to think about when it comes to municipal water supply. And for comparison with rainfall, it's best to express flow volumes in inches or millimeters of depth over a contributing area. So just like we talked about the acre foot, sometimes it's better when we're talking about rainfall just to think about, it's a 2-inch rainfall, 3-inch. And we're also talking about that over the contributing area, and a lot of times that is just acres. For example, a 1-inch depth over 1 square mile equals about 53.3 acre feet. It is desirable that annual values of runoff represent a period beginning and ending during a time of low flow. So if we want to get those annual runoff values, we want to start with the low flow, and end with the low flow. And how exactly do we do that? Well, the total runoff for a single rainy season is included in the runoff year. And so we use something called the water year, which is what's used in the US. It's a period from October 1st all the way up to September 30th of the following calendar year. So we're not just talking about, when we're talking about, this year of rainfall, most likely we're talking about the water year, which is that October 1st to September 30th, because toward the end of summer, we're not going to have crazy high flows. If you start in January, the flows are going to be very high because we're in the dead of winter. But right at the end of summer, the flows are going to be very low. And then starting in October, we're not having crazy big rainfall events quite yet. The general pattern of normal annual runoff is quite like that of precipitation, but modified by soil and geologic characteristics and many other factors. So although runoff will be related to precipitation, the natural environment that the rainfall is falling in is going to make a big difference. We have soil that infiltrates well, we're going to get less runoff. We have soil that doesn't infiltrate well, we'll get more runoff. What is the area sloped like? What is the geography? That's going to play a big difference in terms of how much flow and volume we're going to have. The more precipitation generally appears as runoff in the cool, moist regions of the country than in dry, warm regions where evaporation is high. And then variations in stream flow throughout the year are controlled by the precipitation distribution. In most of the country, the ratio to runoff to precipitation is lowest in the summer, but in the West, heavy runoff from melting snow occurs during spring and early summer, even though precipitation during this period is light. So you might get more stream flow in the summer because of all this melted snow, although there's not a lot of precipitation. And then let's talk about evaporation and transpiration. Evaporation is the transfer of water from the liquid to the vapor state. We've known this for a long time. We're taught it in elementary school. And then transpiration is the process by which plants remove moisture from the soil and release it to the air as vapor. And close to 2/3 of the precipitation that reaches the land surfaces of the earth is eventually returned to the atmosphere by a combined process of evapotranspiration. And this will consume a large amount of the water that we have in reservoirs. The rate of evaporation from a water surface is proportional to the difference between the vapor pressure at the surface and the overlying air, and this is known as Dalton's law. The vapor pressure is small in still air, so air that's not moving, there's not a lot of vapor pressure, and the evaporation is controlled by conditions at the surface from which evaporation is occurring. And there's some more factors listed. And then loss from soil cannot exceed the water available in the soil. Obviously, we can't lose more water in the soil that isn't there. And then evaporation from snow or ice can occur only if the dew point of the overlying air is less than the temperature of the snow surface. And then the dissolved salts will reduce the vapor pressure of the water surface, and then saline water will evaporate less rapidly than freshwater sources. So that's going over stream gauges, evaporation, and transpiration. Later, when we get into lesson 12, I hope you enjoyed this lesson. Please download the hydrology terms guide down below to help you out, and we'll see you guys next time.